Hi friends, you know that we are now in the sixth week of prognostics and health management, a systems approach. And of course, here the enabler for this advanced approach is AI/ML, which provides assurance against the reliability matrix, in the sense that in PHM, we do not allow failure to precipitate such that it has got the catastrophic effect, catastrophic in the sense of the failure really exists. In PHM, we make the effort that we track the degradation and thereby we take the corrective action so that the instant of failure does not happen. That is the objective. Okay, and that is where the machine learning or deep learning it is playing a very important role, because we need to track the degradation, and not only tracking the degradation but generating the information regarding useful life of the component, so that the management of the plant can plan corrective action, and that way we get into the management module of the health management component of a prognostics. Okay, and that is how. So today we will be focusing on more of statistical and probabilistic, because statistics and probability, they play a significant role in developing the deep learning, or I would say generally AI together, and that is where we can say that total things are divided into two parts. One is the statistical method, and second is ANN algorithm. There are many algorithms, and those we will be discussing. But in this lecture, mostly we will focus on statistical methods which are used for training, learning, and the prediction component of the PHM. So we start with 6 weeks. Outline is like this. First, I'll introduce the subject, what is there in the next 4 modules. Okay, so that we are like warming up here to understand the different machine learning or deep learning algorithm. And in the second lecture, we have systematically the 2 fundamental approaches, that is supervised, unsupervised, I would say 3, reinforced learning. These things will be studying or we will be discussing in the second week, and third and fourth week, they are dedicated to the probabilistic methods, how it supports the machine learning, and and some of the techniques like likelihood estimation, they will form part of the algorithm in A. And in B, we will be discussing. So you can say A and B will be discussing the probabilistic method, and in last lecture we will discuss the non-parametric algorithm. Now, why parametric? For lecture 2 and 3 are dedicated to the parametric methods. A broad difference between parametric and non-parametric method is in parametric methods, our data which we collect from the field or a ecosystem, they are in such a way that can be expressed through a probabilistic distribution. That means we can apply our probabilistic method or different distributions to understand or extract the feature of the data. It could be mean, it could be variance, it could be other properties. And in non-parametric method, the data is there, but it is not fitting into directly into any distribution. So there are two ways. We take the data and try to assess its applicability to one of the available distribution if the data is discrete or your data is continuous in both the cases. But at the outset we don't have idea of. So one is to like we do in graphical method. We plot the data and we see whether a straight line is coming on the exponential plot, then it is a straight line, then it is an exponential distribution. If it is coming straight line on a log normal graph, so these are all approximate methods. There are some regression, other method also we'll discuss to get a good idea about. But broadly you can understand when the data is not following exact, which we don't know rather I would say, which distribution it is following or it is not following any distribution. So there are ways to model this data, and that we do in last, we'll discuss in last module, that is non-parametric algorithm. So having given the background about the week, let us see first see what is ML/DL role of statistical method. And first of all, let us understand what is AI, ML and DL. I had shown earlier also, and this I will be reinforcing many times as and when it becomes relevant during a lecture. So why AI we need? Earlier we were using the typical statistical methods, and we were solving our problem of maintenance management. For example, let us say frequency of maintenance we have to work out. So we have the failure data, and based on the failure data we will understand what is the frequency of maintenance, that is maintenance interval or test interval we will work out. The problem is it is something like related to non-linearity or complexity of the system. The mega systems, they are so complex in nature, especially when you talk about the main machine interaction there. So failure might have a dimension of human performance, or might have a dimension of its own domain together, like I have been mentioning common cause failure, and these things should be avoided. So in short, we can say system have become complex, so we need advanced methodology, and that is where there is now a consensus that AI ML or artificial intelligence, broadly speaking people call as a group artificial intelligence, can solve many problems, and research in the labs and even in the field shows that AI ML, due to their learning capability, their training capability, they perform much better than the linear programming or the classical statistical models, where we used to have probability and all. And that is why when we talk about the reliability using statistical approach, we get the probability of failure. And then when you use the PHM and this kind of technology, the reliability means instant of failure. So a domain person is not sure what he will do about the probability, though probability is useful in identification, prioritization and all that, but he don't know if high and low what it means in the control room of a plant. So what he says, if you give me the instant of failure, or when it's going to failure, that is remaining useful life, it is useful me. And that is exactly prognostics and health management. It does. It is one of the major goal. And we know that we cannot always give the instant of failure, or rather we can. So there we have one probabilistic method where we characterize the uncertainty. So what we are doing is, randomness is inherent component of any operation, any design, any maintenance action. So that uncertainty, randomness associated uncertainty, we are modeling, and we are saying instead of giving a specific event or epoch of time when it's going to fail, we are telling this component, just for example, will fail in 33 days. So it will give a upper bound and lower bound also, 28 days to 37 days. Now you see what a beautiful tool we got with us. Nobody wants exact instant, but they want information very close to that. And if you can do that, it is a big benefit for the O&M. Whenever I use the word O&M means operation and maintenance ecosystem, be it a plant or any other platform. Once I got this information, that means now I have to use my lineup resources in a manner that one is the safety is not compromised because safety is overriding factor. At the same time, my main business objectives, that is, and its bottom line, they are also not affected. And at the outset, let me tell you one thing again, that one component failure normally does not affect plant operation, but if there are combination of, if there is a threat to the redundancy, diversity, okay, then there is a issue. So PHM does that job also. It works on the plant environment also, which are basically, it could be plant environment, doesn't mean always process parameter, temperature, humidity and all. It might be in the training level of people. That means it involves management also. What kind of management consciousness is there? It is a more holistic compared to any other conventional technology. For example, we are talking about the data-driven system. Okay, huge data is available. This is one of the advantage of the present ecosystem, that we have huge experience on plant operation and maintenance. And what it means is we have data available with us. Even if it is not there, these kind of tools and techniques, they inspire the O&M ecosystem to have the data, because this data becomes teacher for us. And how to teacher means it provides more understanding about my component failure characteristic or performance characteristic, I would say. And then data is there, and now we are lucky that in this era we have computational facility, we have data analytics working to our side. So these two, and availability of tools and methods. And so because ANN or this kind of algorithms, they will work more effectively if we have data in a format and in an extracted form. So that's how for present machine learning system, the data processing is integral part of the ANN before the data is fed to the machine learning algorithm. And second is feature extraction. That means provide those salient feature of the data to the learning algorithm, so that it is easy to handle and prediction is much better. So we can say overall we are now at that point of time when machine learning can provide for whether it is a any societal system or any technical system like railways, aviation, or it could be energy system, so that reliability and safety, they appear to be going in two different directions. People are really having this, if I improve the safety, whether I should focus my attention on plant availability and all. No, if you can focus on component performance, you will be addressing both, because we are addressing both safe failure as well as unsafe failure. Safe failures are those failures which affect the reliability. Plant, there is no threat. But unsafe failure are those failures which has risk consequences. Okay. So that both of them, when we do have a tool like PHM, it can be addressed. That is the beauty. One is data-driven technique. But now in material science, our understanding of material, how they degrade or how their performance get degraded at material level, at interface level, there is a better understanding. So physics of failure approach is available. So what basically is done is, in earlier lectures you might have seen the data-driven and physics of failure approach, they are coming together, and that in turn they are reducing the uncertainty in prediction. So this is the background about this, And since we are saying statistical analysis methods, they are at the core of it, we'll be spending more time. So that generally, if we want to understand, because 30 or 40 years ago, or maybe before that, we had only artificial intelligence. And in the artificial intelligence, we used to have rule-based system and artificial neural network. But in those days, these things, they were not as popular as it is today, because predictions were going on, and there was a question about the data, about modeling and all that. But all those issues have been resolved. So now we have artificial intelligence, and then machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So when we talk of deep learning, these are things which are supporting the deep learning approaches. Okay. So generally what we say, when there is a dependence on ANN, then we call it as a deep learning. Deep learning is a integral to ANN, or ANN is integral to deep learning. Here we have statistical methods, here also we have these methods, and this field together, if somebody wants to call, they can call artificial intelligence, where machine learning and deep learning, they are at the core of it. That's what we have here, So now deep learning, what we mean by deep learning actually. So in artificial intelligence, there is a demonstrated capability of learning. I mean, even since the time of ANN, artificial neural network, some 40 years ago, or maybe before that, the capability of ANN to learn, to remember, that means it gets coded into the a binary form, as a strings of binary things, and then it was possible to train, learn, and store the data. So don't you think that it is almost like a human-like capability we imported to the machine? In fact, when this capability was imported to the machine, there are some advantages, and like any good thing has got its a flip side also. Similarly, ANN also has some flip side, and that's why now the current ecosystem, they are really careful about the risk or security aspect associated with the intelligent system. So now when we are talking about learning, learning can happen. I have a supervised learning. That means I have a label for different vectors or different images or different input for my data. So I'll train my deep learning model to identify these things, and so with this supervised learning, levels are identified, computer has been trained, or algorithm has been trained to identify this, and even some variation. The beauty of this learning approaches is there. If the image is little bit varying or not exactly matching, then also it can predict with a rider that the last goal, root mean square error, or any other matrix, it will tell, but the RMS error is more than the standard acceptable level, and this exactly is in line with a human. That's how we work. If some face is there, we look at it, try to analyze it, and then we say, okay, let us go and shake hand with this fellow. He appears to be the same person. So, and you finally, either 99% you will be yes, and 1% you will be. So again, error is part of anything. So then, so this is called supervised. That means every data set has got a label. So it is called supervised learning. If this is the pattern coming into the plant, this is the output. If this is, so don't you think it is becoming so important and relevant, because for example, you assume a control room of a complex plant. Now, if the data suddenly, due to some transient, if it floods the control room, the human, he scans this or scans across the screen which data is coming and their sequence and groups and all that, and it takes time. But since a computer was trained in this, we had trained them for finite number of conditions which are 95, 97% form part of any transient, and you have trained it. So that means indexing onto a particular situation evolving there, it comes immediately, because sensors are providing the signals, signals are forming the patterns, and patterns have been trained, and that output has been label was there, output label was there, and you did it a job in advance before the transient had occur. And in that transient also there are some transient which are anticipated type, like power failure, and there are some transient which may not happen all through the life of the plant, and you have trained for that also. The kind of assurance that you got with that is tremendous, and all these things they are working on statistical models. Now, there are some situations where is unsupervised learning, like I have some collection of data, but I am not sure what data is what. But then if I have some features there, and then if I can measure the distance between the feature that you have and how far it is. So however big the data is there, we can categorize and classify this data. So this is called unsupervised learning. That means computer is trained for the data you just present them, and based on its algorithm and little bit of training, it will be able to, not training, modeling I would say, it will be able to categorize the data into using some matrix is there, like distance, and other things. So it will be our shape or size and all. So it will be able to do it. So it doesn't require label in this type of learning. So it is called unsupervised learning. Now third one is reinforced learning. Reinforced learning is there are some agents, there are some actors, and then it will see incentive and whatever, and then it will learn. The algorithm is self-motivating type of thing. If there are rewards, I should go in this direction. If there are no rewards, like a child does that, what is to be done, what is not to be done. We'll come to that in details. So now at the outset, as I mentioned, the AI is inspired for human, how things, information flows in the brain, how perceptions are formed, how rationals are formed, how decisions are made in the frontal lobe of a brain. Probably that is the biggest learning that has happened and inspired the programmer or AI experts to design the AI tool. So as we know that fundamental entity is neutron, and the information flows from one neutron to another neuron, and that's how they form a collective opinion. And basically the processes that are there, they are happening at the chemical level, but we'll not go into that. We'll say how 10 neuron together, they sensitize other stimuli, they generate a stimuli for the next neuron on the line. Then those remaining neurons, they propagate and all. So we can say, so in a nutshell, if I have to understand AI, machine learning and deep learning followed. At the center, it is the deep learning. Now there are many definitions of artificial intelligence, and we are trying to reflect on this definition using human attributes. Okay, and that finally provides a peep into what it means by deep learning at functional level or machine learning. So you know that the first of all, as a constituent component, AI is dedicated, tools are there, statistical analysis tools are there, then rules are there, and multi-layer level analytics is there. So these three are maybe many more, but these are the three which are specific to artificial intelligence. And then Russell and Stewart, they have given a definition of AI. Let us see how it fits into the systems approach and all. So artificial intelligence is the capability of computational system to perform tasks that are typical to human intelligence, such as learning, reasoning, and problem solving, decision making, n number of attributes, reacting also. So the definition does not capture human capability in respect of AI. However, um, one more and final attribute which we should attach to artificial intelligence is how safe or how it is protected for like random safety risk, and then it should be able to have security risk. So we don't have any machine. So it is not an open domain. These two, and as of now, the way the articles are appearing in the open media, it is more than that actually. So we will have our own definition for the purpose of this course. But before that, we'll say why artificial intelligence? When we have the natural intelligence with the human, why we need artificial intelligence? Point number one, we know that there are some complex data, and that need to be resolved. So sometimes it goes beyond the reach of a computational facility. So one reason, complexity of data. I mean, sometimes it becomes prohibitive actually, and we are handling in data only. You can also say this century it belongs to the data, and we are investing a lot of resources in data, and we are equally getting benefited also. We can see this in around us. AI has almost like dominating, or has become one of the important tool around us. So that is complexity of data. Then search strategy. As a human, we also make a search. But suppose if I train a person, and if I train a human on the, at least on the roadmap, human could be more intelligent, could be more innovative in that sense. But then what happens to the plant configuration, where what to do and when to do, how to do, has been trained to the machine. Now in machine, the uncertainty appears to be more, especially for emergency condition. During emergency means plant emergency, or there is some situation where task has to be done, but the human are under stress, and we all know that under stress our capability to think, like you are driving a car, normally you are an expert driver, but let us say the shortage of time itself has become prohibitive, and we tend to do mistakes, and that is where, so like now you think about a mega plant where plant is running smoothly, and suddenly there is a transient, and in this transient it affects depending on the type of event. If it is a postulated event, if it is a rare event, or some phenomena, then it takes a toll on tend to take a toll. It will not take always toll. It affects, but it adversely stresses. They affect our cognitive capability. Now there, in that situation, a trained computer has been installed, and is taking decision. So though this trained computer or a AI module or a AI tool has been trained in all that, it helps the actual human being to take the decision, because now there is some friend with him actually, and it is based on the signal that are coming in, it is given its prediction, and actual action will be taken. Some are autonomous action, but some are autonomous or automatic action, but some actions has to go, when we are talking about the safety and all that, it has to go through human only. So between whatever has been delegated to human, that human will take action, those kind of action human finds a friend in such tools, and then he is the person. It is not a feedback loop which is going and closing it. So for such situation, AI works very well. And then we have some jobs in software where the ecosystem is not having issue of software itself or safety itself, but security also comes into the picture, and then sometimes we have the target, sometimes we don't have a target. So that is the situation we are in. So now we have understood why we need AI tool to help human in taking decision in complex scenario. The tasks have become so data has become so complex that it is not humanly possible to take the action. Even human, it thinks for some time. A simple case where during the daytime we take decision, it takes less time, but in night around 5 o'clock, if we are then it affects, because we are slightly moving from, it's not that we take wrong decision, but it takes little time which is delta x more than the original time. So for such things, AI tool can be a good support. Okay, it is called operator advisory systems. Then risk potential of AI, I was mentioning to you that. So here we can say that our topic is PHM and systems approach. So that means we want some management action to be advised. Okay, or so then it is not prognostics alone. Many applications, they do prognostics, they predict, and they say PHM, but no, it is not that. Systems approach. In even systems approach, so say simply sometimes you have this failure mode effect and criticality analysis. So that is good for characterization of microstructural thing or failure mechanism and all that. But at plant level, we want to understand what action to be taken. Not deep science, but based on the plant topology, plant condition, what action to be taken. So that can be done by, so a risk evaluation should be done for this even AI tool also. Why? Because we are concerned now about AI security, AI safety and security both. So now, having this discussion as a background, what should be the definition of artificial intelligence for safety critical system? So here the definition I am giving is artificial intelligence is defined as the capability of computational system to safely and securely perform tasks that are typically associated with human intelligence, such that it surpasses human capability, okay, and robustness. That typically include, but not limited to, learning, reasoning, problem solving, breeding, new AI. In fact, developing now AI itself is breeding generative AI, we can call, to a new tool. So perceptions is a very important phenomena when it comes to the plant management, that lead to inference in general and decision making in particular. So we have closed the topic. We have brought in the you can say overriding metrics, that is safety and security here, and then different human components we are able to relate, and we are talking about decision making. We are not telling AI should be operating in closed loop. Wherever our automated systems are there, automatic actions are there it's fine. But that anyway happens also using the typical electronics, conventional electronics methods and all that, or mechanical systems all. But then wherever that domain is not there and human, we are depending on like a pilot operating, how he takes the decision and how he manages the scenario during emergency, and that is the reason why human factor has been considered to be contributing to the accident, is one of the major contributor to the contributing to the accident. There some more deeper analysis is required. When we reach a figure of 90% and 80%, probably if we do a deep root cause analysis, many management factors will come out. But human, of course, it is natural. Human is involved in conceptualization. Human is involved into the preliminary design, operation, maintenance. So human only will be. But then that is not a correct thing that human contributes. Human do wonderful job. Let me say at the outset, they operate 99.99% the plant safely, okay, and the remaining 1% that attributing to human factor, and without root cause analysis, we have to consider and do a detailed analysis. So we got the definition. Now same way machine learning we are defining here as a subset of AI is defined as computational algorithm. Rest of the things more or less will remain same. Here I am taking credit for human capability also, because for the reason I have discussed in the previous slide. Okay, so ensure safety and security and tasks typically performed. So that means we don't have any doubt when we talk about the machine learning. We have connected to risk and security aspect, and that should be the overriding factor. Okay. Now, how deep learning looks like? When we say it is ANN branch of a sub branch of ANN, then we have to look at first this figure. You know, when ANN came into being, or say when they were invented initially, we used to have only one hidden layer. This one major difference. Now we have three hidden layers actually. Why? Because we want to infer from the each level, okay, or consolidate our output, or filter, I would say, our output at three or more level, which was not the case earlier. It used to be one input layer, one hidden layer, and one output layer. So this itself gives how we progressed in AI, or you can say deep learning, for its application, which is becoming so popular, and it is because of this reason. So I would say the difference is, and of course, before the input layer also, two more layers are there, which I'll show later on, or what I would have shown also in previous lectures. That is, one is pre-processing of data. Process the data and remove those, if suppose noise is coming with some signal, I have to remove it. Feature extraction. Instead of putting the whole algorithm, or streaming the data, I can put mean value, standard deviation. Just for example, I am doing. There are many more things that has to be done. So that then it becomes more crisp, and it doesn't load the ANN, or the algorithm, and the results are much better. Okay. And so one is multiple layer, and then so I am giving the pre-processing and feature extraction, the input layer, multiple hidden layer, and the output layer. Okay, and then there are advanced tools to for prediction. As part of either supervised learning or unsupervised learning or reinforced learning. So that makes the success story. The final objective is to train the computer process to domain specific problem possessed in a way human brain performs operational. Actually, human brain is a wonderful machine, and it does really enormous jobs, and we want that any job we do with more efficiency, but it should be in line with how human thinks. So that is what our objective is. It should be comprehensible, and it should be rational based. Rationals are very important and core component of deep learning and its application. Now, training part of, first we have to train. Training of the machine learning algorithm starts with input layer. Okay, we have talked about the pre-processing and feature extraction, and now input layers have been formed. So these data are there, and at each node, the data signal along with weightage factor, and the weightage could be between 0 and 1. Generally, during the training, it is kept at very low level. So this is the significance of weightage. Okay, so this assigning weight is a very important attribute, and then finally an activation function, which they come to a transient node or input next node. They all connections are, so you have seen ANN one node at the ith level connect with the jth node, all the nodes in the jth layer. So that's how it happens, and weightage has to be given, and improvement in weightage, actually value is 0 to 1. So it goes on improving during the training from 0 to 1, 0.01 weightage to, let us say it goes to 0.9, 0.99, 0.95, and that's what it reflects on the error at the node and at the output layer, both here. And one of the very popular training algorithm is feed forward and back propagation learning, in which the computation starts from left to right, okay, from input node to output node, and then whatever error signals are generated, this is part of the training I am trying to explain. And then whatever signals, it is not reached the desired level. So again it will go back. It will go on improving the weightage, or you can say the convergence which occurs. So when training happens, this convergence happen, and finally when it comes to a value of, let us say, 10 to the power minus 3 or 4. So now you can say the learning error is coming down, and the NN has been trained. This value is ranging from 10 to the power minus 3 to 10 to the power minus 4. Root means square error. Okay, so and number of iteration, it depends on computer. Earlier days it used to take 10 lakhs, or 10 to the power 5 iteration or 10 to the power 6 iteration. Now it takes very few iteration, because computational facilities have really improved. So this is all about training. So if I say in this week, if I have to sum up, we have discussed AI, ML and deep learning and their training, not procedure I would say, but we have discussed how the training happens and convergence occurs, and of course before that there was a introduction and background. So probably you are now in this week itself you are acquainted, if you take in isolation, about ANN, and then difference between level of AI, machine learning, deep learning, and essential features of deep learning.